Hi, my name is Alej Martinez. Today, I'm going to talk about our project Compound Facial Expressions of Emotion. This work was done here at The Ohio State University in conjunction with my colleagues Xishuan Du and Yong Tao. As we all know, faces and emotions play a very important role in our daily lives. As nicely illustrated in this quote from an unknown philosopher of the 4th century BC, it has been long known that felt emotions can be broadcasted to the world by means of facial expressions. But how many of these facial expressions can each of us produce and recognize? Philosophers and scientists have debated this question for centuries. Duchenne, a French neurologist of the 19th century, set out to prove there is a unique set of facial muscles we employ to express each emotion category. As shown in the image on the right of the screen, Duchenne triggered muscle contractions with electrical probes to prove his theory. Darwin, who was at the time working on his theory of evolution by natural selection, suggested that if these expressions are indeed consistently produced and perceived by most people around the world, then this may have a biological and evolutionary root. Darwin suggested there might be at least 6 emotion categories that fall in this theory: happiness, sadness, fear, anger, surprise, and disgust. In the 1970s, Paul Ekman and colleagues devised a mechanism called Facial Action Coding System, or FACS, to demonstrate that the facial muscles used to produce facial expressions of these emotion categories are indeed consistent within each category and differential between categories. FACS allows researchers to answer these questions without resorting to the use of electrical probes. This is done by identifying the muscle activation in images. Each activation referred to as an action unit, or AU for short, as shown here. Different numbers refer to specific muscle actions. However, everyday experience suggests we employ many more facial expressions of emotion than these 6 basic elements. For example, when we see the 2 images shown in the screen, we have no problem distinguishing them. One corresponds to a happily surprised expression, while the other displays angrily surprised. Happily surprised is an expression you may observe when a friend receives good unexpected news. In contrast, when the unexpected news upset your friend, you may observe an angrily surprised expression, or perhaps a sadly surprised or disgustedly surprised expression. This suggests that there are different types of surprise emotion categories. We call these categories compound emotions because they can be constructed by combining or compounding 2 of the basic categories mentioned earlier. In particular, we consider the 21 basic and compound emotion categories shown in the screen. The top left image corresponds to a neutral expression. A neutral expression is defined as the absence of any muscle movement. The 21 emotion categories correspond to the 6 basic emotions mentioned earlier and compound emotions, such as happily surprised, fearfully angry, fearfully surprised, and angrily surprised. We collected the images of these emotion categories plus neutral for a total of 230 individuals. If these facial expressions of emotion correspond to categories readily employed by humans, then the production needs to be consistent across these 230 individuals. To study this, we FACS-coded the entire database, which includes close to 5,000 images. The table shown here lists the consistent action units used by our subjects. Let us refer to these action units as prototypical AUs. In parentheses, we show the AUs that are only used by a subset of people. Note how the prototypical AUs are different for each of the emotion categories, demonstrating that the production of each facial expression of these 21 categories is different from the others. We also note how the production of facial expressions of compound emotions is consistent with the AUs of its subordinate categories. For example, when expressing happily surprised, people use AUs 1, 2, 12, 25, and perhaps 5. 1, 2, and 5 come from the expression of surprise, whereas 12 and 25 express happiness. Thus, the muscle actions involved in the expression of these 3 categories are different but consistent with what they communicate. With the above, we have demonstrated that the productions of the facial expressions of these 21 emotion categories are different. That is, people consistently express these emotions in a similar manner. Next, we wish to understand if the resulting images are visually distinctive from one another. This is necessary because we do not directly perceive the movement of the facial muscles. Rather, when we look at the facial expression, we see shape and shading change. Are these changes consistent within categories and different between them? To answer this question, we built a computational model. Our model automatically extracts shape and shading changes from the image. It then uses machine learning algorithms to determine if the images of each emotion category are similar to those in the same category and different from those in other categories. The results show that they are. In fact, classification results obtained with this computational model are extremely similar to those observed in humans. That is, the computational model misclassifies, more or less, the same images that people misclassify. In conjunction, these experiments suggest that a large number of emotion categories can be readily produced and potentially identified by humans, and that this number is much larger than previously thought. If you wish to learn more, you can read our paper in the Proceedings of the National Academy of Sciences. You will find these and related works on our website, shown here. This research was supported by the National Institutes of Health. Thanks for listening.